Let me guess. You think you know what the word serverless means. A function managed by a cloud provider. And when you choose to use serverless, you have to deal with cold starts, you have to deal with a completely different deployment model, and generally just a whole load of other complexity. Things like Lambda, Azure Functions, Cloudflare workers, all them serverless things that I'm guessing you either love or absolutely hate with a passion. Now, I'm here to tell you the way you're thinking about serverless is wrong. Serverless is a spectrum, and I'm here to prove to you why that is. Let's chat, I think, Scott, about what serverless actually is. And I think this is really interesting. I think I said this in a couple of videos ago, actually, but I was at a conference a couple of years ago. It was a serverless conference. And there was a guy there whose organization built everything on top of Kubernetes. But the individual developer just pushed a container image to a registry and magic happened. The app got deployed. And he argued that he had a serverless experience because he didn't have to care about underlying infrastructure, even though it was Kubernetes under the hood.
I think for lots of devs, anything like that is super valuable ultimately, like modulo the details, of course. Because mostly you just care about your code, right? You write some business logic, you map from one domain model to another domain model, you have a little UI in the front. This is the thing you're interested about. Everything outside of that, taking that and making it run somewhere, it feels like undifferentiated toil, right? Why am I doing exactly the same thing bespoke over and over again to make this totally normal application run somewhere every time I build another totally ordinary application? It seems like a waste.
It definitely does seem like a waste. But I think one of the really interesting pushbacks when we think about serverless functions, and I'm going to really specifically use serverless functions here, is the local developer experience. And I think the last couple of videos we've done where we've talked about hexagonal architecture, about synchronous and asynchronous, and about the flexibility that gives you, one of the things we've done with Stickerlandia and we've demonstrated in the code repo that's linked in the description is this ability to run the exact same application code in a container and in a serverless function. Now, this is really powerful for a couple of reasons. Generally speaking, long-running synchronous workloads better suit long-running containers. It's there, it's waiting to receive a request, everyone's happy. And when you're running that locally, your local developer experience is fine. When you've got these more reactive, event-driven processors that better suit serverless functions, because you've got this ability to move things around, when you're running it locally, you could potentially even run that locally inside a container and then just deploy it to serverless functions.
I do still think this is a really typical pain point, though. I like the idea of low ops or no ops, but it does feel like unless you're very careful with your abstractions, you end up paying another cost instead. Rather than just having this ordinary thing, you can run locally on your machine as a process and start it, and it connects to queues and processes messages and what have you. Suddenly, I'm exploding it into a bunch of different things in a cloud platform. And I know I can use fancy local emulators like Local Stack. I can architect things very nicely, like we have in Stickerlandia. I can abstract myself back from the requests model itself, whether it's evented or whether it's kind of like a synchronous HTTP thing. I can do all these things, maybe even the frameworks I'm using support that. But it still makes it feel like it's less of a clear win in absolute terms. And again, here, I'm a big fan of containers personally. You have a process, you wrap it up, you ship it somewhere, it runs on your own machine. It's good times, and it's very easy to reason about as well, I think.
Yeah, a very, very well understood mechanism as well, right? Like, I think serverless containers are often the right place to start for building any new application. Like 18 months ago, I was a lot more of a serverless maximalist, and I was like, serverless function, all the things, everything should be a serverless function. And I think that was dumb. If I look back on past James, I even once did a conference talk that was actually how to build an entire application without any compute. So it was all like step functions and native service integrations. And I look back on that talk with horror and dread. Because I do think for a lot, like, if you're building something net new, like build your application with a well-known framework, whether that's .NET, Java, JavaScript, Rust, Python, whatever it is, use a well-known framework, package it up into a well-understood, well-maintained, well-known medium, a container, push that to a service that allows you to run that container with very little operational overhead. And then later, maybe you do decide that a serverless function is better for its workload, and great.
Yeah, I think insofar as you can use lots of modern frameworks to do that abstraction for you, it's a super reasonable way to think about it. Like container by default, and then you can say, hey, this thing here, like it's a periodic cron task, or it's reacting to an event stream or something that's super fluctuating. let's just take that off, run it on the side. And because we already have this nice abstraction, the cost of doing that is very low. And because you've still kind of built your foundation on the idea of containers, you still have the flexibility to move between cloud providers very easily. Once you go down the point where you've bought into the functions a little bit more, I think you have to expect a little bit more friction moving that component. But you still rely on the same abstraction there, right? You should still be in a position where you can, with not too much additional toil, flip between function providers.
And I think as well, like most of the serverless function providers that I know of support containers as a mechanism for packaging your application up. And historically, that was slower, at least for Lambda, it was slower and it was more expensive. But now it's the same price as running it with Zip. And AJ Stivenberg, like serverless hero, but fellow Datadog, has got a really interesting blog post where he did a lot of analysis on containers versus Zip packaging, and there's negligible performance difference between the two.
Cool.
Which
sounds like a good thing to have a link for at the bottom of the video.
And like an excellent thing to have a look at. Have you done this YouTube thing before? So to wrap up, to give you some really concrete takeaways, one of the really interesting ways to think about serverless, I think, is as a spectrum. So of course, at one end of this spectrum, you've got functions. The things at this end of the spectrum have your lowest amount of operational overhead. This is where you can take something, run it, it will scale up, it will scale down, it just runs and it reacts to things. But as we've kind of talked about in this video, this next kind of layer down, you've got things like Azure Container Apps, Amazon ECS with AWS Fargate. You even got some European cloud providers now, companies like Scaleway, that allow you to simply take a container image and run that. And I would consider that serverless from a sense of you've massively reduced your operational overhead there. You're running these container images. It's nice and simple. It's well understood, and you're running that without worrying about the underlying infrastructure. Obviously, of course, as you continue down this spectrum, you end up in services like GKE, AKS, EKS, Kubernetes, before finally ending up at your virtual machines. And obviously, off the end of the screen, down at the other end of the room, is running a server under your desk in an office. But you've got this spectrum of compute choices, and generally picking the place to start based on what is the simplest thing for you right now. But remember, serverless does not equal functions. Start with serverless containers. I think serverless containers plus a Postgres database probably solves 95% of all application workloads, right? Like, I think starting with something as simple as possible, so you have a really convincing reason not to, is really good practical advice. Starting with something as simple as possible might be that the company you're working for at this moment in time happens to have really good tooling for serverless functions. Great, use that, do that. And then finally, that thing we've talked about in the last few videos as well, separating your managed service specific code from the actual business logic. That keeps you that flexibility. It allows you to move things around in the future if you need to.
James, I think we finally converged on our views about serverless.
Maybe.
Great. So yeah, I think next time you start a new project, you should try serverless containers first. You might be surprised by how far it has come since the early days of serverless. And you might also end up in a position where you don't need to use anything more elaborate or fancy. And again, if you want some examples to get started, check out the Sticklandia repository linked below the video. We have all sorts of fancy deployment models, including serverless containers. Thank you for your time.